In this short video, we will show how to use functions within scripts and also introduce another feature that you can use in a function, which is the so-called persistent variable. To do this, we're going to write a function called SumUp. And I create a new function as before, and I give it the name SumUp. And SumUp is going to take whatever individual value we give as x, and it's going to return the total so far obtained from all the previous values of x. Now, since x is a local variable, this value x and also the total value here is deleted at the end of every closure of the function call. But we can get around that by having a variable which is defined locally within the function, which I can ask MATLAB to keep by using the declaration persistent. So I'm going to call this this sum or something like that. And the way in which I'm going to make the function keep a tally of the total value of all the values of x that have been given to the function, each time I call the function, I'm going to add x to whatever I happen to have in this sum at that point. So that's that there. And I can now return the total by asking it to be given the value of this sum. Now there's something missing from this function. I'll save it first and then explain what might be missing. Of course, the first time I call SumUp from the command line, there won't yet be any value of this sum. It hasn't yet been given a value. So what I want to do is have an if statement that asks if this happens to be the first time I've called SumUp, then can I check for that, and can I then define this sum to have the correct value? So the function for doing that is called isEmpty. Just check that that's the right name for it, isEmpty. I'm going to do a help on that, and you can see here isEmpty. So if I have isEmpty this sum, that will return a value true if this sum isn't there, and it will return false if it is there, which is slightly back to front. But what that means, if I type if in front of that, then remember, if this expression evaluates to true, it means that this sum is not available, which means I now have to define it. So I'll take this sum equals 0 and then put an end. So these three lines of code are checking to see if this sum has been defined. And if it hasn't been defined, I define it and assign a value of 0 to it. And now this function ought to work. So if I now do SumUp of 2, the answer is 2. And if I run it again, the answer is 4. And this remembering of this sum within this function is only possible because I've asked for that variable to remain defined even though the function call has ended. But notice that this sum has not been made available in the global workspace. It has been preserved, but is internal and only usable within this function SumUp. So it's an internal persistent variable. It's a local persistent variable. So each time I call this function, I can call it with a different value, say 5, you can see that the sum has been preserved. Now let's create a script file and see if we can use that. So in this script file, I'm going to save the script file immediately, and I'm going to call it sumUpNumbers.n. And I'll put some returns in and put a comment in, sums up a list of provided numbers. Okay, now of course there will be a function within MATLAB that will do this for us, but let's see how we can use the SumUp function to do the same job. So let's define a list of numbers. I'm going to define a list of numbers, x equals, and these could be readings, for example, from some kind of measurement. Maybe not a very good measurement because the numbers are varying quite a lot. Okay. I'll put a semicolon on the end. So that's the list of numbers that we're going to sum up. And of course these can in principle come from a file, if we like, and be provided from somewhere else. So we obviously, to do the sum up command, we need to have a for loop which now loops over all of those elements of x. And the first element of x is index 1, and the last element of x is given by length of x. And put an end on the end of that. And in order to sum up all those values, we can simply say sum up xi. Okay, so each time I call this function, whatever value of I have is given as the index of x. So if I is 3, then the third element of x will be extracted, will be 4.3. This will be passed to the sum up function and will be added on to whatever sum is already there. We'll put a semicolon on there because we don't want to print that value out. But let's keep a running total. Let's say total so far is equal to sum up of x, because the sum up function is returning the value. Okay. So I'm going to save that and I'm going to run it, and some of you will have noticed there is actually going to be an error about to occur. So I'm going to sum this up, and we'll ask for total so far. Ooh, do that in the command window. Total so far. Okay, it's 34.2. That's actually wrong. That's much bigger than the numbers here. Because what I've forgotten is, of course, that sum up function is still remembering the values that I entered into it when I was testing it earlier. So rather than having to quit MATLAB and restart, perhaps I can clear those values out. Well, let's see if we can do that within the function. Let's say we want to pass the function some particular value which isn't going to be something that we're going to want to actually add onto the function. Now this, again, is a little bit of a hack, but let's try it out. So let's see if we can find, I mean, there is this number infinity, of course. Let's try inf. There we are. So inf is a number in MATLAB. There we are. Unlike some other programming languages. So inf is a number that I can pass to MATLAB. It can be stored as a variable. I can say a equals inf, and it's an infinite number. And if I do a plus a, it's still infinity. So it seems quite happy to use infinity as a value. But obviously it doesn't mean anything if I add infinity into my sum function. So I could have another test that say if x equals inf, then I can reset this sum as well. This sum equals 0. There we go. So if I call sum up with the argument infinity, it should reset the sum. Let's see if that works. So if I say sum up of inf, well, that doesn't seem to work, does it? This sum equals 0. Ah, of course, what we've done here is I've forgotten not to add the infinity on. So what we want to do is have an else statement here and put an end statement here. There we go. And now we have, I think, what we should be doing. So if we call the sum up function with the value infinity, it will reset the sum to 0. Otherwise, it will add on that value to the sum. So we'll save that, and we'll call the function. So by calling the function from the command line, you can see we're able to test it outside of the script. So we can separate out our debugging, our fixing of the various bits of code into smaller pieces. This is a very nice feature of MATLAB. So now if we do sum up of 2, 4, yes, that all seems to be working. So if we go back to our our script that's going to add up all the numbers, double click on that, or of course if you notice that any open file in the editor is available as a tab. If you've got very many of them, you may need to move them around a little bit, and I think you can pick them up and drag them around if you wish, but I'm not going to do that. Oh, there we are. I can move them somehow as well. I'll try and put that back. There we go. So you can see there's different ways I can display the code in the integrated development environment. If you get stuck, it is possible to, in some versions, to go back to the default layout, which I can't remember how to do right now, but we'll have a look at a bit later. So you can see if I want to sum up a list of provided numbers, one thing I can do to make sure that my script here is not using previously used values of the sum function, I can say sum up inf to start, and at the end I can do final result equals sum up of 0, and I want to explicitly display final result, and I think now we have a complete program. So if I run that, you can see that it's now summed up all of the values in this list. So let's just recap what we've done. We've taken a set of values, x, and in order to sum them up, we use the sum up function with 3 different ways of calling it. By calling it with the value infinity, which is not useful to the sum up function as we've defined it, we then reset the sum internally, this persistent this sum variable on the left here, which when we then call the function again with finite values of x, will total up internally to the sum up function the total so far of all those values that have been provided, which is being done on this line over here. Finally, in order to obtain the final result, we can then call the sum up function one more time and add nothing at all to it. So of course, this definition here, I can actually delete that and not keep defining the total so far. I can take that sum up function, call it, and the return value that's given by it, it just gets thrown away. So that should also still work. So let's run that one more time and show that it gives the same answer, which it does. So that shows how to call functions from within scripts and how to use persistent variables.